Good day everyone, my name is Lady Jade Baha from Group 3 Discussants, and today we will be discussing the factors that causes and triggers natural hazards. One factors that causes and triggers of natural hazard is the ENSO, or El Niño Southern Oscillation, a naturally occurring climate pattern that involves fluctuation in sea surface temperatures and atmospheric circulation in the tropical Pacific Ocean. It has three phases, which is the El Niño, neutral or the average sea temperature, and La Niña. ENSO events occur regularly every 2 to 7 years and can last for several months to over a year. ENSO influences phenomena like monsoons, hurricanes, and droughts, making it critical component to the global climate variability. El Niño are characterized by warmer than average sea surface temperatures in the central and eastern Pacific Ocean. It typically leads to altered weather patterns such as increased rainfall in the eastern Americas and drought in the regions of Australia and Southeast Asia. La Niña are characterized by cooler than average sea surface temperatures that generally result in opposite effects compared to El Niño, such as wetter conditions in Southeast Asia and drier weather in Western Americas. To fully understand what is El Niño and La Niña, let's watch a video.
It influences weather patterns across the world, from America to Antarctica to Australia. From the Spanish for little boy, it's known as El Niño. Its other cycle is La Niña, or little girl, with the in-between phase called neutral. The swing between these phases forms the El Niño Southern Oscillation, or ENSO, one of the most important climate drivers in the world. ENSO is a major influence on Australia's climate. El Niño and La Niña events can cause natural extreme events such as bushfires, drought, heat waves, floods, and cyclones. As the Earth spins, trade winds stream across the planet, driving warm surface seawaters across the vast Pacific Ocean. These sea surface temperatures create predictable patterns of circulation in the atmosphere and ocean. Climate scientists gather data from ships, weather stations, ocean robots, and satellites to measure the swing between the three phases of ENSO: neutral, El Niño, and La Niña. A La Niña event tends to bring above average rainfall to eastern Australia. During an El Niño event, there is a greater chance of drought and bushfires. Each El Niño and La Niña event lasts about 6 to 12 months. It takes on average 4 years to cycle from El Niño to La Niña and back again. But no two El Niños are the same. The strong 1997-98 El Niño impacted every continent in the world, causing widespread devastation worldwide. This story begins in the eastern Pacific. Here, trade winds blowing from east to west push warm surface waters across the planet, piling up warm water in the western Pacific. Above the ocean, warm air rises, driving atmospheric circulation patterns known as Walker circulation. Cold, nutrient-rich waters upwell in the coastal ocean, replacing the warm water pushed away by the trade winds. Like an athlete pumping iron, the La Niña is the muscled-up version of the neutral phase. Trade winds become strong, and more warm water builds up in the West Pacific. The excess of warm water increases evaporation and precipitation, causing floods and forming tropical cyclones off the northeastern Australian coast. This warm water escapes through the gap between Indonesia and Australia to supercharge the Lewin Current, a 5,500 kilometre long flow of warm waters along the Western Australian coast. But, like an athlete, the winds can't keep pumping at this speed forever. Sometimes the winds weaken and warm water sloshes back across the ocean to the East Pacific. The Walker circulation breaks down, weakening or even reversing the trade winds. warming of the eastern Pacific accelerates, setting off a feedback loop that keeps most of the rain-producing evaporation in the middle of the Pacific. Due to the movement to the east of warm surface waters, northern and eastern Australia experience clearer skies, higher temperatures, heat waves, and increased risk of drought. Off the coast, fewer tropical cyclones form, as tropical activity is concentrated further east. Off the coast of South America, upwelling of cold waters is suppressed, and warmer surface waters result in higher than normal rainfalls and sometimes flooding and hurricanes. In Western Australia, the Leeuwin Current tends to be weaker and cooler during El Niño events. During the 2010-2011 La Niña, marine waters that were up to 5 degrees warmer than usual caused mass deaths of marine life, as well as coral bleaching along the Western Australian coast. However, warmer La Niña waters are generally beneficial for species such as the western rock lobster, whose larvae ride the Leeuwin Current southwards. In La Niña years, more lobster larvae settle to the ocean floor, meaning greater numbers are available to fisheries. 2015 is the first strong El Niño in 18 years. In the future, understanding when, how, and why these events happen will help us to manage the risks that they bring.
ENSO events can have significant impacts on weather patterns and natural hazard. Weather patterns altered precipitation patterns, increase or decrease storm activity, and changes in temperature. Natural hazard increase risk of floods, droughts, and wildfires in different regions. Examples of ENSO events influencing natural hazards includes El Niño and La Niña. El Niño increased rainfall and flooding in South America and droughts in Australia and Indonesia. On the other hand, La Niña increased hurricane activity in the Atlantic and droughts in the American Southwest. Another factors that causes and triggers natural hazard is the anthropogenic. Human activities have significant impact on natural hazards, increasing their frequency, intensity, and severity. One of the human activities that causes and triggers natural hazard is the deforestation. Deforestation is the clearing of forests for various purposes has significant consequences for natural hazards. Deforestation can cause soil erosion, which is the removal of tree covers exposes soil to erosion by wind and water, leading to landslide and sedimentation in waterways. Landslides, in which deforestation weakens slopes, increasing the risk of landslide, especially during heavy rainfall. Floods, deforestation alters hydrological cycles, reducing water infiltration and increasing runoff, leading to more frequent and severe floods. And lastly, the climate change. Deforestation contributes to greenhouse gas emissions, exacerbating climate change and its impact on natural hazards. Examples of deforestation contributing to natural hazard is the Amazon rainforest and Indonesia. Deforestation in the Amazon has led to increased soil erosion, landslide, and changes of rainfall patterns, impacting to the region's vulnerability to floods and droughts. Deforestation in Indonesia has contributed to severe flooding and landslide, particularly during the monsoon season.